Hi everybody, my name is Sean Sublette and I'm a meteorologist at Climate Central in Princeton, New Jersey, and we want to talk a little bit about the basics of climate change. It is happening now and it is largely human caused. Some of the impacts are irreversible, but the short version is the longer we wait, the worse it's going to get. So the actions today can limit future warming. And it does impact us as humans in the form of extreme heat and heat-related illnesses. Heavier rain, which leads to flash flooding. Droughts. Droughts are a natural occurrence, but they are made worse with the higher evaporation rates in a warming environment. In turn with that also comes larger wildfires. Again, wildfires are a natural occurrence, but they spread faster and they spread farther in a warming environment. And as polar ice melts and glacial ice melts into the oceans, the sea levels rise, which in turn leads to more coastal flooding. Revisiting the atmosphere in general, most of it is nitrogen and oxygen, and only small amounts of greenhouse gases, including carbon dioxide, water vapor, methane, and even nitrous oxide. But water vapor, as potent as it is as a greenhouse gas, gets out of the atmosphere fairly easily, and that's in the form of rain or snow. The greenhouse effect works this way. As the sun heats the ground heats the atmosphere above it. And some of the energy in the atmosphere then goes back to space and back down to the ground below. In fact, without the atmosphere, Earth would probably be about 60 degrees colder than it actually is now. Now, climate has absolutely changed naturally in the past, but on a much longer time scale. There are small variations in the Earth's orbit, the axial tilt, and the precession of the equinoxes. In other words, how the Earth wobbles on its axis, which redistribute how solar energy comes into the planet, and in turn, really drives the ice ages and these periods that are a lot warmer. We go back and look through things like ice cores, corals, sediments, trees to determine how the climate has changed in the past, and to tell us a lot about how much warming we're seeing today compared to deep into history. And when we do look back at that paleoclimate record, it suggests to us that for at least the first time in 800,000 years, and some studies suggest 2 million years, carbon dioxide in the atmosphere is far greater than it has ever been in the history of human civilization. And there's a pretty good correlation with CO2 and global temperatures. It's not perfect. There are other small fluctuations like pollution and, of course, solar output, volcanoes. But over the past century and a half, as carbon dioxide has gone up, so has the global temperature. Certainly not the sun. The temperature in the red curve there has really jumped since the 1970s, even though solar output there in yellow has started to flatten out or even fall a little bit. And the climate models we hear so much about do a reasonably good job at reconstructing the past, as well as looking toward the future. That blue curve is what we would expect if there were no greenhouse gases. The climate model basically does a pretty good job matching the orange and the green curves there with what's going on in the real atmosphere. And we've largely seen this since the Industrial Revolution. Burning fossil fuels leads to carbon dioxide, methane, and nitrous oxides. These have all happened basically over the last 100 years or so. Their concentrations really jumping in the last 50 years. You hear so much about carbon dioxide because it's the dominant one. It stays in the atmosphere to hundreds, if not thousands of years. Basically, once it goes up, there's no easy way to get it out. Methane is a stronger greenhouse gas, but it has a much shorter lifespan in the atmosphere. Most of the CO2 and otherwise greenhouse gases come from transportation and generation of electricity, with much smaller amounts from industry, heavy industry like making concrete and steel, and other commercial and residential things, as well as a smaller amount from agriculture. But it's largely generating electricity and moving us around. And there's widespread dominant consensus on this in the scientific community. You may hear of a very small number of people who disagree. They tend to get a lot of press, but they are in the dramatic minority. There is large spread consensus on this throughout all scientific organizations around the globe. And we've seen this. The hotter times have already arrived. It's been more than 100 years since the Earth had a record cold year. And the 10 hottest years on record have all come within the past 15 years. Also lost on this is how much energy is going into the ocean. In fact, the additional greenhouse gas energy, 93% is going into the oceans to warm the temperatures up there. It takes a lot more energy to raise the temperature of water than it does the air. And we've seen that over the last 20 centuries. When we look at some of those old school climate records, if you will, the sediments and ice cores, they suggest that the sea level rise in the 20th century is unprecedented in the last 2,000 years. And the number of record highs we're seeing also illustrates that as well. You see the number of record highs has really jumped with respect to the number of record lows set over the past 3 to 4 decades. It's harder to break record highs unless you're doing some kind of warming, and that's exactly what we're seeing. Now, we get heavier rain because there's more water in the atmosphere in a warmer environment. Warmer atmosphere means more evaporation from oceans, lakes, rivers, and soils, and that could lead to heavier precipitation. In fact, some of the heaviest downpours, the amount of precipitation has jumped more than 50% in the Northeast, by more than 25% in the Southeast. Western part of the United States, which is generally a drier climate to begin with, has also seen the numbers go up, but not as dramatically as we've seen east of the Front Range of the Rockies. And there is still going to be snow falling in winter, but there won't be as much with respect to rain. In other words, there is going to be more rain falling in the winter at the expense of snow. Snow will still fall, but all those states you see in green have started to see more rain falling versus snow. Droughts have always happened in the western United States in particular, but they are slowly and steadily getting worse. Again, more evaporation in a warming world worsens the drought. The drought always happens, but because there's more evaporation, the soils dry out faster, as does the vegetation, which makes them more susceptible to wildfires. The future decisions we make are going to play a large role in determining how much warming we're going to have in the decades to come. If we start cutting back on greenhouse gas emissions, basically how much we use fossil fuels, that will really decrease the amount of warming we should expect in the decades to come. You hear a lot about climate change attribution, or how much did climate change impact a particular weather event. Climate change never causes the weather. However, it does influence it by looking at current and historical weather observations, and then simulations, or what we call mathematical models, that both include and exclude greenhouse gases. Scientists can look at all those things together and determine the role of climate change in a particular extreme weather event like Hurricane Harvey, which largely is expected to, which most studies have suggested that anywhere between 10 to as much as 20% more rain fell compared to if we weren't in a greenhouse gas environment. So as we go forward into the future, what should we expect? Well, carbon dioxide remains in the atmosphere for hundreds to thousands of years. So no matter what we put into the atmosphere now, it's going to lock us into additional impacts: rising sea levels, more extreme heat, and heavier rainfall. Again, these aren't set in stone. The sooner we act, the less intense these impacts are going to be. So we could increase energy efficiency, reduce waste. You've seen all the pictures about the plastic all over the place, but just reduce waste. So if you consume less, that means we're using less energy. And if you do have the means, you could explore electric vehicles, but you don't have to have a lot of money to do something to help regarding climate change. Some resources to keep in mind. NASA has an excellent climate page, climate.nasa.gov. They have extensive resources and lots of interactives and videos to learn more. You can look at the National Climate Assessment, which was put together by the U.S. federal government in 2017 and 2018. And of course, our organization, Climate Central, has several resources you can tap as well. You go to medialibrary.climatecentral.org. If you want to watch a video, I would recommend an excellent one called Earth, the Operator's Manual. This was put together by Richard Alley at Penn State. He's a geoscience professor there. It's about an hour long, but it goes through a lot of what I've talked about today. And finally, if you have a question, if you want to follow me on Twitter, you can do that at Sean Sublette, or send me an email, s.sublette@climatecentral.org. Thanks for watching. Hope you learned a little something, and by all means, learn more. Go to those resources and understand where the true science is on climate change. Thanks so much.